All right, first off we have, this is the project for definitions of sine and cosine. And first off what I have done, I've brought this down here to answer question 1. We're going to set that up right there, estimate that. It's kind of hard to get it exactly at that spot. Got to go up just a hair. Close enough. And we're going to estimate, is that about 37 degrees? Yeah, look at there. That says 37.1 on our nice little thing right here. So yes, I would agree that this one is approximately 37 degrees. So let's put an answer right here of yes. Okay, I don't write very neat, but that answer is yes. Okay, the next thing we want to do is measure. Now, this is not going to work out perfectly for our calculus. I want to do like the ruler here. I know this, if I can get it to drag down here, I don't know if I can get it to turn and everything like what I want. Okay, kind of like right here. I'm just going to kind of do this one. I've measured these out previously, but this does set out to be a pretty good example in our centimeters here. And this U1 is pretty close to 4. All right? We're going to call it 4 for easy measurement purposes. So let's make our color right here. Let's make this here. And we'll say U is 4 centimeters. My little centimeters are not showing up too good. All right. Now, I don't know that I can get this thing to turn. I guess that's what this here is. Yeah, there we go. Looky there. And this one here, if I get this real close, is close enough that we're going to call this one here the hypotenuse. We'll call it 5 centimeters just for easy purposes by measuring. All right, and then I don't know, we'll go right here, probably put that right there, and then twist this one down here like this, as such. Oh, that's part of my problem. As I adjust this here, it's changing my length of my. Can't get it to keep coming, baby. Oh, get back in my ruler here. Maybe that'll like quit marking up the wall there. Oh, one more time. As we struggle with this here, it's almost funny. All right, we're just going to cancel that there. I've measured it before, and I know that it turns out to be 3 centimeters. So we just answered like those particular questions right there. All right. Now then, what I want to do next is the following. Let's erase. Have those answers start down there. So let's erase our stuff right here. I made a big mess over everything. All right. Let's go ahead and answer some of our other questions. Now I need to erase this right here. I don't know if that'll scroll up with that or not. Okay. And then here we go. Oops, I've got to go back to my, I'm trying to think how this worked out here. I'm not used to this here, so grab my pen and slide this down so we can do these other questions. Oh, it went away. Where'd it go? There we go. Back to this right here. Gotta be real careful how I do this. All right. So here we go. You will recall from the previous, the sine is what? Opposite over our leg. So if we look at number 3, if we had to remember, opposite here was this was 3, this one was 4, and this one was 5. So if we go over here, we talk about sine, our opposite being over our leg, that would be 3 over 5, which is a decimal is 0.6. All right, and if I go here to cosine, let's change the color up on this one here. Well, that would be the adjacent, which is 4 over 5, which would equal about 0.8. Okay, so we're right there with it. Now the next thing I want to do is this, and you know I forgot to pull up. So what I'm going to do right here second is minimize this one. Oh, I forget how to get this Here we go. Back to right here. Let's minimize that a second. Oh, left all that still on the board. It'll come back up there a second. But what I want to do is the following. I'm sorry, I forgot to pull this up. I'm going to pull up my Wabbit menu. Hopefully it will come up here. All right, so let's go back to what we have right here. Back to my Wabbit menu. All right, and let's do the following. With the calculator here, I'm going to do the sine of 37 degrees. If I can get this to slide over just a little bit more. Having real trouble here today. Sine of 37, let's turn it on. And let's make sure our mode is in up. It was not. We need to make sure it's in degrees. All right, enter. All right, and now I'm going to see here. I'm going to do sine 37, enter, and I get point. Oops. Okay. Let me see here. I want to bring. What I want to do is this here. This was 0.6, I know it was 0.601 something. And as I bring the calculator back, oh, I keep forgetting to do this here. Got to keep hitting that there to do the following. I don't know that it took it. All right, maybe I should use the other part here, be a little smarter. Notice it's 0.6018. Which is very close to 0.6. All right, I want to try to do the cosine of 37. Enter, and notice this one is 0.798. All right, let me pull that down right here. 0.798, 0.798. My numbers aren't coming out too nice looking there. But aren't those very, very close? If you look very close, they're very, very close to what we had right there. So that's really good. All right, let's move this back to the other side just so that I can, oh boy. All right, let me see. I think right here. I'm not used to this here. There we go. Up. Okay, there's my little marker. That's what I want to do. So I'm going to decide right here. Because what I want to do is the following. I want to move this back up here. Let's answer these questions here. All right. So first off, let's trash all that we have written. The definition of sine and cosine can be extended to angles that measure rotation with the aid of the reference angles. Let's sketch one at 125 degrees. All right. So let's sketch one at 125 degrees. So right here, let's do this nice blue one. So start our angle right here, and about 125 degrees would be something like that right there. All right, that's my regular angle. Okay, I want to calculate, and that's 125. So what I want to calculate now is this angle right here. Well, if all the way across is 180, and that much is 125, well, that little bit should be what? 180 minus 125, which makes a reference angle what? 55 degrees. So what this is talking about right here is this. So if I go back to my calculator, oh, got to put my little thing back on right here. We'll use this one here. It seems to have less trouble. And I pull up my calculator. And let's move this back to the other side here. All right. So now then, as I go to my calculator, let's do the sine of 55. Enter. And we get this nice 0.819. We'll call it 819. Can't really make it there. 0.819. My writing's terrible on this thing right here. All right. And then next we'll do the following. We'll do cosine. Oops. Got to put it back on. I'm learning. Back on cosine here. 55. Enter. And let's just go to this right here, and we'll call that, it says 0.57. 57, all right? So now then, we'll call that 0.57, and we'll round it to 6, okay? Now then, let's look at number 7 here. The formal definitions of sine and cosine are this: the vertical coordinate divided by the radius, and the horizontal coordinate by the radius, which basically means sine is the letter y, in blue, it'd be the letter y divided by your r, and the cosine will be the x divided by the r. But if you come here to your calculator, and let's just do this here, let's just do sine 125 and see what we get. And notice we get the exact same what? So the sine of 125 is the same 0.819, okay? And let's do cosine. The cosine of 125, oops, cosine, got to kind of clear that marker there. Cosine 125, enter. And notice this time I get, for the cosine of 125, I can't write this pen, I get the same number, but it's negative 0.576 when rounding, all right? So my nice little markers aren't real neat there, but we get the idea. Why did that happen? Why did we get the same values, but yet they were different numbers? Well, that's kind of what this here, that's what this here lesson's really all about. Okay? So let's, first off, let's look at what we have the list right here to help answer those questions out. Okay, let's go back to right here. Let's see if we can trash those out of there so we can see what we got. Well, the reason is because we're talking about x and y values. Whoops, trash those out right there. X and y, notice everything is positive in quadrant 1 here. X and y are both what? Positive. They're both positive, correct? But what happens over here in quadrant 2? Well, the x is negative, and the y is positive. It's kind of hard to tell those right there. And we get over here in quadrant 3. Well, what happens is what? X and y are all what? Negative. And then in quadrant 4, the x is positive, and the y is negative. All right, that's what I was asking for right there. So, and that's the reason that we have those values where 125, notice the reference angle for 125 and 55 was the same angle, the same values, it's just that when x is negative, your answers was negative for cosine. And so that's what reference angles kind of help us do, is find the values, and then by the quadrant it is, we determine whether the answers are positive or negative. Don't forget for question number 9 to tell us what you learned. We answered all the questions. Do not leave that one blank. And tell me what you learned from this. Thank you. Thank you very much.